Welcome to the second session. Like I said, we'll be going into networking. So networking and operating systems, we talk about the basics of computer networks. Then we have types of network, PAN, LAN, MAN, WAN. We'll go into like what they are, like the full name and what they are in the coming slides. Then we'll briefly get into operating systems. What are operating systems? So first is basics of computer network. So what is a computer network? A computer network is a collection of interconnected devices such as computers, servers, routers, your cell phone, just anything that can, get connected, that can make use of the internet. So it's a collection of interconnected devices such as computers, servers, routers that can communicate and share resources. Then next we'll talk about the key concepts of networking. First is a node. So a node is a device that's connected to the network. Like I said before, it's a collection of interconnected devices. So these interconnected devices, such as our computers, our servers, our routers, that's what node is. So in networking, a node is a device or point of collection that participates in data communication within a network, such as a computer, router, or switch. Then we'll talk about link. So a link is a connection between nodes. So if your phone or your laptop is connected on the internet, the link between what is that? Okay. So the link between your device and the network, the connection, is basically what a link is about, what a link is. So a link refers to a physical or electrical connection. It can be wired or wireless. That's why we have Wi-Fi. Wi-Fi is wireless, and then there's also wired. Then okay, so links can be wired or wireless, facilitating communications within a network. Then we'll talk about a protocol. So protocols in networking are rules governing data exchange between devices. They define the format, timing, sequences, and error control during the communication, and it ensures compatibility and standardized interaction in network. So we'll explain what it is like in the upcoming slides. I think we'll be able to like understand it more the more we go through the slides. So IP addressing. IP addressing in networking is like giving a unique address to each house in a neighborhood. So let's say, for instance, you have like 5 different devices. We are all connected on the same network, but each device has its own IP address. So in computer networks, every device, like your computer or your smartphone, gets a unique IP, which is your IP address. Yes. So this addresses helps data find its way from one device to another. Then next we talk about the functions of networking. First is data sharing. Data sharing in networking is like friend sharing notes. Device in a network such as computers or servers exchanging information. So now like we're all connected to the internet, and data sharing, we share like information from one phone to another, from one device to another, such as like you're sending message, you're sharing data, it's moving throughout the network. So protocols like rules for passing notes guide this exchange. It enables collaborative tasks such as file sharing and communication, allowing connected devices to access and contribute to shared information seamlessly. Then we'll talk about communication. Communication in networking is akin to talking on the phone. It is very similar to talking on the phone. So devices such as your computers, your routers use protocols, use rules to exchange information. So data travels as packets similar to spoken words through a network. Okay, there will be some words throughout the slides that not everyone will know the meaning of. So at the end of the class, we can explain more on what these terms are. Then resource sharing. So devices in a network such as computers or printers share their capabilities and services. So resource sharing is like, okay, for example, um if you're working in an office, so we know that every staff will have their own computer, every desk will have computer, just an example. But then it's very possible that not all the desks will have a printer. So like for a floor, there can be just one printer that everyone in that room shares. So that's resource sharing. They connect all their devices to the printer. So that's also networking. So this cooperative sharing optimizes resource use, allowing multiple users to access and utilize sharing resources like files, printers, or processing power efficiently. So like, if it's not efficient, it's not effective if every computer system has its own printer like right beside it. Like let's say like there are like 10 people in like one office, just an example, and then everyone has their computer system, everyone has their printer. It's better for them to make use of just one big printer, because you're not going to be using a printer all the time. So as long as it's all connected through the network, everyone can make use of just that printer. Then would be so far, does anyone have a question or like an input they would like to add to this? No question. Then next I'll be talking about the types of networks. The types of networks. First is PAN, which is known as personal area network. A personal area network is like a digital bubble around you. It connects devices such as smartphones and laptops within your immediate space. So like making use of things like hotspot on your phone is like you're sharing data to another device. So if that device decides to leave the room you're in, you're not going to be able to connect to it again. So it's like it's just in your area where you are right now that you can connect to it. If you're making use of like a Bluetooth device too, like you're making use of your headphones and it's Bluetooth is connected to your phone. So like, for example, you leave your phone and you go outside and you're listening to music, you'll notice that at some point your music will start cracking because it's not close to it anymore. So a PAN is just like a connection that is around you. So like I said, it's connected devices like smartphones and laptops within your immediate space. Bluetooth and Wi-Fi often form PANs, enabling seamless connections for sharing files and using peripherals or creating network with devices in close proximity. So it's typically within a few meters. Then next we have LAN, which is a local area network. A local area network is like a small neighborhood of connected devices, such as computers, printers, and servers in a limited geographical area, like your office or home. For example, like there are some companies or some offices where they have their own like Wi-Fi. You can only use it in the building of the company. So that's like an example. So yeah, Ethernet or Wi-Fi enabling efficient data sharing, communication, and resource access among connected devices. Then next we have MAN, which is a metropolitan area network. It is like a city-sized internet bridge. It connects multiple local area networks within a metropolitan area. So this one is like I explained before, LAN. LAN is local area network. But metropolitan area network it connects multiple LANs together. So when you have like 3, 4, 5 LANs together, that's what becomes a MAN, a metropolitan area network. So it connects multiple local area networks within a metropolitan area, facilitating data exchange between buildings or campuses. So MANs uses high capacity of fiber optics, providing efficient and fast communication for businesses, universities, or organizations in a specific urban region. Next, we talk about WAN. And WAN is a wide area network. It is like a vast city of interconnected neighborhoods. WAN can be like around countries or even continents. So it spans a large geographical area, connecting lands over long distances through technologies like internet or private networks. So like the internet is a prominent example of one, because like so many devices are connected to the internet. Like someone that's in Asia, someone that's in Africa, they are all connected on the internet. So that's an example of wide area network. Then we have wireless LAN, which is one yes, WLAN, wireless local area network. It's like a digital playground without wires. So for example, LAN typically it has wiring. So an example of a wireless local area network will be like your Wi-Fi that you use. So it's wireless. You connect. You just have to find the Wi-Fi name, enter the password, and you're connected to it. So wireless LANs enable seamless communication and data sharing within a limited area, just like the LAN, like your homes or your offices. Then we've spoken about networking, like types of networks, the key terminologies. Then we'll move into introduction to operating systems. So does anyone maybe have an idea of what an operating system is? Like you can type it or unmute yourself and then give an answer. An operating system is a software that manages computer hardware, software resources, and provides various services for computer programs. So, for example, this Windows operating system, like if you're making use of HP laptop, you're definitely using Windows. So, Windows was developed by Microsoft. It's widely used in personal computers, like I said, like HP. It has a user-friendly interface. So we'll talk about what a user interface is in the comment slides. Then there's also Linux. It's an open source operating system. It uses servers, embedded systems, and desktops. It is known for stability and security. So with the way I've like just briefly spoken about Windows and Linux, like can anyone think of any other thing that might be like an operating system? Do you have an idea now of like what an operating system is? Like for example, if you're making use of a Samsung, like what software do you think you're making use of?
Android.
Exactly.
Hello, Android.
Yes.
Android is an operating system.
Thank you very much. So if you're making use of like a Samsung, you use Android, and then if you're making use of an iPhone, you're probably making use of there's a different one for Apple, and then what did you say? Sorry.
For making use of iPhone, make use of iOS.
Exactly. Thank you. And then there's also Mac OS if I'm making use of like a MacBook or like MacBook Pro, something like that. Yeah, exactly. Thank you very much. So moving on, we have the functions of an operating system. So why do we need an operating system? So first is a processor management. So a processor management allocates and schedules tasks for the CPU, ensuring efficient usage. The OS prioritizes and switches between processes, managing the execution to optimize performance and maintain system responsiveness. Then we have memory management. In an operating system, an operating system is like organizing a library. If everything is like just all over the place, I don't think your device will be able to like function properly. So it oversees the allocation and retrieval of computer memory for programs. The operating system ensures efficient utilization, preventing conflicts and optimizing performance. So the memory management basically keeps track of each program space, allowing smooth operation and preventing one program from interfering with another. Next one would be file system. So a file system in an operating system is like an organized filing cabinet for digital information. Just like you have like a physical file, you arrange your documents one by one, just so you don't mix up whatever you need. So that's what the file system on your operating system does too. And we have user interface, which is a UI. It's basically what you can see. Like when you're using an application, the buttons you can see, like the color, the functions of whatever operating system, whatever application you're using. That's what user interface is. So a user interface in an operating system is like a visual bridge between the users and their computers. It presents a graphical or command-based environment for interaction. So like, for example, when I was explaining Windows, I said it has a user-friendly interface. That means like when a person that's never used Windows before and they try to use it for the first time, I'm sure they'll be able to like walk around this, like understand what is going on, because the interface is user-friendly. And then for the file system's memory management, there's something called so basically it just shows like what parts, like it shows, you can search on your computers if you have it on your system, and you can see what type of process, what type of task is going on right now, because you can see what you can see right now is not everything that's going on. There are things going on in the background. So that's basically what the memory management is all about.
You mean something like performance monitor and system
Exactly,
monitors?
exactly. And then next, I'll briefly talk about the user account and permission. So first is the user account. We have the individual profiles. So each user has a unique account. For example, like just an example, you have your social media account, you have like your Instagram account. So every user has a different account. You have a different ID. For example, you want to sign up on Instagram and you put an ID. You say, okay, I want this username. Instagram tells you this username has been taken. So you can't have two users with the same username. That's impossible. And then we have the login credentials, username and password. Then we have personalization, the user specific settings and preference. So this is what the personalization is, basically what you can see like on your user interface. Like for example, some people like dark mode. They're making use of an application and they'll ask you, do you want it on the regular mode, do you want it dark mode? So like personalizing it to fit your preference. And then we have permissions, which are the access control. So the access control determines what resources a user can access. Like you're making use of your computer, but it's not everything you can access. Like for example, Windows, I didn't say anything about open source, but like when you're making use of Linux, it's an open source operating system, which means like you can alter the operating system to fit your preference. Then we have read, write, execute. It defines actions allowed on files or directories. So a directory is where like all your files are stored, and there's some files you can see and you can decide to, okay, delete the file, you can edit the file. So that's basically what it's about. And then we have administrator privileges. So administrator privileges are special permissions for the system level task. So like I said at the beginning of the lecture, there'll be some terms that I'll just want to explain more in case we maybe like don't know what they are. So first is a server. So a server is a powerful computer that provides services or resources to other computers, clients in a network. For example, Netflix. So on Netflix, there are like so many dramas, so many movies you can watch, and then whatever data is there, they make use of a server to store the information, like all the movies. So that's a server. Like it's not just on the internet, there's a server keeping everything. So they can decide to remove a movie, add a new movie. So that's them altering the information. So then there's a router. A router is a device that's directing traffic between networks, facilitating communication between devices in different locations. Then we spoke about packets also. So a packet is a small unit of data that's transmitted over the network. It contains both the actual information and control information. So whatever information you're trying to transfer through the network, you can't see it physically, but it's there. It's through the network. Talk about Wi-Fi. I'm sure like most of us know what Wi-Fi is, or actually everyone probably. Then, so a wireless technology allowing devices to connect to a network without physical cables is what a Wi-Fi is. And then there's Ethernet. Ethernet is standardized wired network technology. Is typically using cables to connect devices in a local network. So Wi-Fi and Ethernet are very similar. I feel like the main difference between both of them is the Wi-Fi is wireless, but the Ethernet, you need an Ethernet cable to connect to the network. Then embedded systems also came up during the lecture. So embedded systems are specialized computing systems integrated into devices like appliances or automobiles for specific functions. So like whatever device you have, like for example, our televisions, even microwaves, even our laptops, like they have like, or cars also, they have embedded systems, and that embedded system is like a small part of the whole system. So they're giving it a specific function. Then we have directories. Directories are hierarchical structures organizing files on a computer or network, simplifying for file management. So when you have a directory, like if you try to open your directory on like Linux, you see several files inside. So it's like directory then files. So it literally organizes your files for you. Then we have metadata. Metadata is information describing other data, like file creation, dates, authorship, aiding in data organization and management. Then we also spoke about fiber optics. Then a fiber optic is a high-speed communication medium using thin strands of glass or plastic. So it's a type of wire, but it's different because it's made from glass, and it enables fast and reliable data transmission over a long distance in network. So fiber optic, I'll say, is like one of the most expensive types of wiring because it is very fast and you can use it for long distance. Like for example, if you have your Ethernet cable, the limitation is the distance, but when you make use of fiber optic, it's very long. You can make it for like longer distance, and it also has a high speed. Then switch, a network device that connects multiple devices like computers or printers within a LAN. It forwards data only to the devices that it needs, improving network efficiency. So does anyone maybe have a question about the previous slides or an input? So I will assume that we all understand what like was just said. So next is
Hello.